Imagine an ordinary midnight stargazing session at a deep space observatory high in the Chilean Andes. Astronomers lock onto the glowing lunar surface, tracking delicate tidal gravitational interactions. Suddenly, without a single acoustic sound or explosion, the moon instantly vanishes from the night sky. Automatic satellite telemetry displays absolute zero reflection, leaving a terrifying void in space. Within seconds, global tidal monitoring stations alert coast guards as coastal waters freeze their natural ebb. The subtle gravitational anchor holding Earth's axial balance collapses in a fraction of a second. Coastal cities experience strange, unpredictable atmospheric pressure drops that defy classical physics. How long can human civilization survive when our primary celestial companion disappears overnight? Will our oceans turn into chaotic tidal monsters, or will Earth's rotational axis wobble violently into oblivion? Welcome to the ultimate scientific investigation of what happens on the day Earth loses the moon. The moon's gravity acts as a massive cosmic magnet, pulling Earth's oceans into a permanent equatorial bulge.
The moment the moon vanishes, that gravitational pull disappears in a split second.
Millions of tons of ocean water rapidly redistribute away from the equator toward the polar regions.
Massive global tsunami surges sweep across low-lying coastal regions without seismic warning. What happens to high-volume commercial shipping lanes when ocean tides suddenly collapse worldwide? Navigational tides drop by more than 60%, leaving major deep-water ports stranded in shallow silt. Marine currents like the Gulf Stream fluctuate wildly, disrupting planetary heat distribution instantly. Deep-sea currents stall, altering thermal gradients that have stabilized global weather for millennia. Marine ecosystems relying on lunar cycles lose their primary biological navigation cues overnight. The ocean becomes a vast, quiet, unpredictable realm, reset by sudden gravitational loss. The moon does not only pull on our oceans, it stabilizes the speed of Earth's atmospheric rotation. Without lunar gravitational resistance, global wind speeds accelerate to terrifying supersonic levels. Hypervelocity jet streams collapse toward the surface, sweeping across continents like invisible walls. Coastal cities encounter relentless hurricane-force winds that shatter glass facades of modern skyscrapers.
Atmospheric pressure zones destabilize, creating unpredictable microburst storms across high-altitude corridors. How can commercial aviation operate when atmospheric wind direction shifts violently within seconds? Global air transport halts permanently as flight paths become completely impassable for jet aircraft.
Dust storms from arid inland deserts billow into the upper atmosphere, blocking out natural sunlight. The sky transforms into a churning arena of dark dust clouds and relentless atmospheric pressure waves. Humanity experiences the raw power of an atmosphere freed from its lunar gravitational brake.
Over billions of years, the moon's gravitational drag has slowed Earth's rotation down to 24 hours. Without this continuous celestial brake, Earth's rotational momentum begins to accelerate over time. Millions of years ago, when the moon was much closer, a day on Earth lasted only 6 to 8 hours. Without the moon, Earth's day and night cycle would shorten drastically to roughly 6 hours long. Imagine living in a world where the sun rises and sets every 3 hours in a relentless loop.
How would human biological circadian rhythms adapt to 3 hours of daylight followed by 3 hours of dark?
Sleep cycles would fracture, forcing human physiology and technology to undergo radical adaptations.
plants and agricultural crops would struggle to execute photosynthesis under hyper-short daylight exposures. And
global weather patterns would spin in hyperfast planetary belts, similar to the turbulent atmosphere of Jupiter.
Earth becomes a fast-spinning, hyperactive world operating on cosmic fast-forward. The Moon acts as a cosmic gyroscope, locking Earth's axial tilt at a stable 23.5 degrees.
This steady tilt gives us our predictable seasons: spring, summer, autumn, and icy winter. Without the Moon's stabilizing mass, Earth's rotational axis begins to wobble unpredictably over time. The tilt could swing wildly from 0 degrees to an extreme, terrifying 90 degrees over centuries.
what happens when Earth's North Pole tilts directly toward the Sun for months at a time?
Polar ice caps melt entirely in blistering sunlight, while the opposite hemisphere freezes in total darkness. Extreme seasonal shifts trigger rapid planetary climate fluctuations, unlike anything in geological history. Equatorial rainforests freeze under sudden polar shifts, while Arctic tundras turn into desert plains. The stability that allowed human agriculture and cities to flourish vanishes completely from Earth.
Our home planet becomes a world of extreme, chaotic climatic swings with zero predictability.
The Moon is the brightest natural light source in Earth's night sky, reflecting crucial sunlight to the surface. Without lunar reflection, nights on Earth become dark, pitch-black voids illuminated only by distant stars. Nocturnal wildlife species that rely on moonlight for hunting and navigation face immediate ecological collapse. Predators that stalk under soft moonlight struggle to locate prey in absolute terrestrial darkness.
Urban environments need enhanced artificial lighting infrastructure to maintain safety and traffic at night.
What happens when global energy grids struggle to power endless artificial illumination for pitch-black cities?
Astronomers gain crystal-clear dark skies for deep space telescopes, but at a devastating planetary cost. The cultural, artistic, and philosophical inspiration provided by the Moon for millennia vanishes overnight. Human poetry, navigation calendars, and mythology lose their ancient silver anchor in the night sky. The night becomes an endless, cold reminder of our profound cosmic isolation in deep space. The Moon's gravitational pull flexes Earth's solid crust continuously in a process known as tidal flexing. Removing this constant stress causes subterranean tectonic plates to settle into a new equilibrium.
Deep subterranean fault lines shift suddenly, triggering cluster earthquakes across continental margins. Dormant volcanic chambers adjust to internal magma pressure shifts, venting plumes of ash into the stratosphere. What mysteries lay hidden in deep oceanic trenches as the ocean floor compresses under shifting water weight? Submerged hydrothermal vents flare with intense geothermal activity, altering localized deep-sea temperatures. The planet undergoes a violent internal mechanical realignment as it searches for a new gravitational balance. Earth's molten iron core experiences subtle hydrodynamic shifts, causing fluctuations in our magnetic shield. Satellite systems monitor solar radiation spikes as the magnetosphere recalibrates against solar wind streams. Deep beneath our feet, the planet is rotating, shifting, and adapting to its new solitary existence. Humanity is forced to engineer radically new underground habitats and aerodynamic city domes.
Advanced artificial climate control systems regulate agricultural growth inside sealed subterranean vaults.
Deep bedrock architecture replaces tall skyscrapers to withstand supersonic winds and axial climate shifts.
Space agencies launch artificial reflective solar mirrors into orbit to replace lost night illumination.
we learn that Earth's habitability wasn't just a lucky break on our planet's surface. It was a delicate, multi-billion-year partnership between Earth and its giant silver satellite. The loss of the moon reveals how fragile the balance of planetary mechanics truly is. Every peaceful tide, gentle season, and predictable day is a gift from our silent cosmic companion. As we look up at the dark, empty sky, we gain a newfound reverence for the architecture of the solar system. The moon wasn't just a beautiful nightlight. It was the silent guardian that made human life possible.
Thank you for exploring this mind-bending planetary scenario with us today.
If you found this deep dive into space science thought-provoking, please hit the like button below.
Subscribe to the channel for more deep explorations into space, astrophysics, and hypothetical realities.
Share your thoughts in the comments. Which effect of losing the moon do you think would be the most difficult? What other hypothetical planet-altering question would you like us to investigate in our next episode? Don't forget to click the bell notification icon so you never miss an upcoming video release. Special thanks to our dedicated community in the US, Australia, Canada, Switzerland, Norway, and New Zealand. Your incredible support fuels our passion to explore the greatest questions about our universe. Keep questioning reality, stay curious, and cherish the beautiful world we call home. Until next time, stay safe, and we will see you in the very next episode.
The cosmos operates on precise balance, where every celestial body plays its part. Understanding planetary mechanics helps us protect and value our world today.
From ocean tides to gentle seasons, our lives are deeply tied to the stars above.
Science continues to unlock the vast, beautiful secrets of our solar system.
As the sun sets, we are reminded of the rare perfection of Earth's cosmic balance. The story of our universe is vast, mysterious, and full of endless wonders. Thank you once again for watching and supporting independent scientific storytelling. Stay vigilant, stay inspired, and goodbye until our next cosmic journey.